Hello, let's try and solve for x in this equation. 3 raised to the power of x is equal to x raised to the power of 9. Let's solve for it. Solution. The first thing we're going to do is to make an assumption. We're going to assume that we'll say let x be equal to 3 raised to the power of k. If x is 3 raised to the power of k, we're going to rewrite the original equation, but in terms of k. Let's do it. So this becomes 3 raised to the power of 3 raised to the power of k is equal to 3 raised to the power of k into brackets 9. Having gotten to this point, we can simplify this further by applying the exponent rule of indices. If we apply the exponent rule of indices, the rule states that if we have a raised to the power of n into brackets m, we can write it as a raised to the power of n times m. So we're going to apply it to this, specifically to this right-hand side of the equation. So when we do that, this one will become 3 raised to the power of 3 raised to the power of k is equal to 3 raised to the power of k times 9. In indices, if the bases are the same, we can equate the powers. So we're going to equate the powers now. If we equate the power, we will now have that 3 raised to the power of k is equal to k times 9 after equating the power. Let me clean this. From this, we can rewrite this equation as, this equation can be rewritten as 3 raised to the power of k is equal to k times 3 raised to the power of 2, because 9 is the same thing with 3 raised to the power of 2. Now, when we get to this point, we'll also make, let's try and divide both sides of this equation by 3 raised to the power of 2. The equation will become divide by 3 raised to the power of 2, divide by 3 raised to the power of 2. When we do that, this is going to cancel out this. So the equation becomes k will be equal to 3 raised to the power of k divided by 3 raised to the power of 2. In indices, if we have a raised to the power of c divided by a raised to the power of b, we can write it as a raised to the power of c minus b, provided the bases are the same. Here we have 3 as the base here and 3 as the base here. So we can apply this rule of indices to this. So let's do that and see where it takes us to. When we apply that, k will be equal to 3 raised to the power of k minus 2. It's at this point that we're going to make another assumption. Here we're going to say let n be equal to k minus 2. If n is equal to k minus 2, it means that k will be equal to n plus 2. Simply moving the minus 2 to this side of the equation gives us k is equal to n plus 2. Now we're going to rewrite this equation in terms of n. If we write this equation in terms of n, k will be replaced with n plus 2 because k is equal to n plus 2. So this k here will become n plus 2. Then 3 raised to the power of k minus 2 will be equal to 3 raised to the power of n, because from our assumption, n is equal to k minus 2. So we just simply took out k minus 2 and replaced it with n. So this is now this equation in terms of n. When we get to this point, we can move n and plus 2 to this side of the equation. This becomes 3 raised to the power of n minus 2 equal to 0. When we get to this point, we are going to go by inspection. When you look at this number carefully, when you look at this equation carefully, if you should substitute n equal to 1 into this equation, what are we going to get? If n is equal to 1 in this equation, let's do it mentally without writing it. Then it means 3 raised to the power of n will be 3. Then in this place, we are going to have 1, and here we'll be having 2. So in a nutshell, when n is replaced into this equation, the whole of this side will be equal to 0. For that reason, we know that n is equal to 1. That is the value of n from inspection. Now, having done that, the next thing we are going to do is that we should recall that from here, k is equal to n plus 2. K is equal to n plus 2. And from this side, x is equal to 3 raised to the power of k. X is equal to 3 raised to the power of k. We have the value of n to be 1, so we can easily get k. And if we get k, we can finally get x, because there is a relationship between x and k from our first assumption here. So let's solve it. K will be equal to 1 plus 2, which is equal to 3. K is equal to 3. If k is equal to 3, then x will be equal to 3 raised to the power of 3. And the value for 3 raised to the power of 3 is equal to, x will be equal to 27. So this is the final answer. X is equal to 27. That is the final answer. Thank you very much for watching. If you find value from this video, please, we urge you to subscribe to the channel for such videos. We are also pleading with you, if you really find value from the video, to like the video, because it helps us a lot. We're just starting. This little gesture will encourage us to solve more questions like this and also give out more maths contents. Thank you.